Hey everyone, my name is Shashank Shekhar, Master Teacher of Mathematics at Vedanta. Here we are presenting solutions for JEE 2018 Paper 2. The question taken in this video is related to the topic limits, continuity and differentiability of functions, various functions. If we look at the problem, there are four functions defined: f1, f2, f3, f4. Certain domains are given, domain and codomain, r2, r minus pi by 2, pi by 2 to r. Then for f3 it is minus 1 to e raised power pi by 2 minus 2 to r. Then f4 r to r. Functions given as f1x sine of under root 1 minus e raised power minus x square, f2 as mod sin x upon tan inverse x not equal to 0, x equal to 0. Pay it is given as 1, where inverse trigonometric tan inverse x takes principal values minus pi by 2 pi by 2 standardly defined. f3 similarly is given something as greatest integer of sine of ln of x plus 2, f4 as x square sine 1 by x not equal to 0, 0 when x equal to 0. f4 is a commonly seen function. If you have seen this function in the chapter limits, continuity and differentiability, is generally presented as an example of some function which is differentiable at x equal to 0 but the derivative is not continuous at x equal to 0. We will see in detail. We'll discuss this aspect of f4. And if you go further, there are two lists given. List 1 may there are four choices: f1, f2, f3, f4. List 2 may there are certain properties mentioned related to continuity and differentiability. Not continuous, continuous but not differentiable. Differentiable and its derivative is not continuous. Differentiable and derivative is also continuous. So we'll see which function will match to which property, will show which will exhibit which property. So one by one, and if you go to the option, see the option says if you check only P, so two option will be rejected if you find the correct matching of P. And further, suppose if you get P as 2, so A and D will be there to check. And for Q there are different options. Similarly, if P goes to 4, so Q we have for Q we have different options. So if we find P and Q, correct matching of P and Q, we will be able to get the correct option, tick the correct option. There is no need to check R and S. However, in this video we will discuss every aspect of the problem, all the four functions. So it will take some time, but getting to the correct option is not that lengthy. Okay, so coming to the very first function, f1x is sine of under root of 1 minus e raised power minus x square. So I'm writing it here, sine of, f1x is given as sine of under root of 1 minus e raised power minus x square. So obviously there is no issue with the continuity at x equal to 0 because everything is asked at x equal to 0 in the list 2, as you can see. So the only set point is x equal to 0. Here you can see f1 0 is 0. I am checking the continuity here of f1x. Limit, for that we'll have to check the limit of f1x, and that is obviously there is no issue, there is no indeterminacy, there is no indeterminate form here. I am getting directly as sine of 0, so it is 0. So limit exists and is equal to the value of the function. Function is f1x is continuous. Now we'll have to check the differentiability of f1x at x equal to 0. For differentiability, going with the first principle, the formula is x tending to 0, f1 x minus f1 0 divided by x minus 0. f1 0 is 0, so I can write directly sine of under root of 1 minus e raised power minus x square upon x. Let's see how this limit can be formed easily. So going with the standard limit, sine theta by theta, theta tending to 0, I am going to write the same thing. Angle for sine here is under root of 1 minus e raised power minus x square. So simplifying it, we will have to multiply it also. So here I am writing e raised power x square minus 1 by x square, and e raised power x square will also be there. So I'm trying to make standard limits. You know, this comes under standard limit into what will I will have to write. Yeah, the only thing left is, yeah, I have written in the denominator under root of x square, so I'll have to write under root of x square here also, divided by original x, this x, so x here. So now this sine theta by theta theta into 0 is 1, under root of 1 is here, and here limit x tending to 0, under root x square is not x, it is mod x by x. So if you see the left hand side of it, you will get minus 1, right hand side mein you will get plus 1. So LHD here is minus 1, RHD here is plus 1. So here we can say that the function f1x was continuous, there is no issue with continuity, but is not differentiable at x equal to 0, isn't it? So here we can see option continuous but not differentiable, so P goes with 2, right? P goes with 2. Coming to the second function f2. f2 is defined as mod sin x upon tan inverse when x is not 0, 1 when x is 0. Mod sin x, numerator. So you can understand even the limit. Okay, I am writing here for f2. If you find the limit of f2 x tending to 0 for to check the continuity. Yeah, what was f2? f2 was mod sin x upon, I think it was tan inverse x, right? X is not 0, x tending to 0. So I'm taking when x is not 0, f2x is this. So if you find this limit now, if I'm writing the standard one, mod sin x by x, and x upon making standard limits here, I will have to write mod x, so in the numerator, x in denominator. Again I am writing getting 1 into 1 sin x sin theta by theta, mod 1 okay. So into 1 x upon tan inverse x when x tends to 0 is 1, very standard limit, and limit x tending to 0 mod x upon x again. So here only if I find LHL it is minus 1, RHL I am getting 1. So here we can see the function f2x is even not continuous. f2x is not continuous at x equal to 0. So obviously not differentiable also. So coming to the list, f2x is not continuous. So P goes with 2, Q goes with 1. Coming to this, P goes with 2, P2, Q1 is given in option D. So option D is the final correct option, must be the correct option. I mean, in exam there is no need to check R and S, but okay, here we'll discuss the characteristics of R and S, F3 and F4 also. So if I am taking F3 here, right, yeah, domain of F3 was also mentioned from minus 1 to e raised power pi by 2 minus 2. From minus 1 to e raised power pi by 2 minus 2, why it is given like this? So if you take minus 1 here now, so you'll get what? Log of minus 1 plus 2 is plus 1, log 1 is 0, sine 0. So it is coming as 0. 0 plus, because minus 1 ka right I am taking. We are taking minus 1 ka right. So 0 ka right, sine 0 ka right is 0 plus ka box is 0. And if you are taking the left of e raised power pi by 2 minus 2, e raised power pi by 2, when you put x equal to e raised power pi by 2 minus 2, so x plus 2 would be e raised power pi by 2 and log of that would be pi by 2, and sine pi by 2 in the left of sine pi by 2, it is 1 ka left, 1 minus, the box is 0. So in the entire this complete domain function f3 is 0 in fact. I am writing it sine of log of x plus 2. Okay. So f3x is basically what I've said, greatest integer of sine of log of x plus 2 the base e, and x is given from minus 1 to e raised power pi by 2 minus 2 minus 1, I think, minus 1 to e raised power pi by 2 minus 2. Yeah, okay, pi by 2 minus 2, right. So in this interval, obviously x plus 2 would lie between 1 to obviously e raised power pi by 2. So log of x plus 2 to the base e would lie between log 1 is 0 and here pi by 2, and obviously sine of log of x plus 2 to the base e would be between 0 and 1. So greatest integer of it, so f3x is nothing but 0. Greatest integer of between 0, some number between 0 to 1, between 0 and 1, greatest integer, so it is 0. So f3x is throughout 0 in the interval, and this interval contains x equal to 0. So in fact the function is flat near 0 in the complete interval given domain. So this function is obviously f3x is continuous, differentiable. Also its derivative f3 dash x will also be 0 because this is flat function for all x given in domain of the function domain, right. So and derivative is also 0 for all x in the domain, for all x belongs to the domain. So obviously going to the option f3 dash, f3x function is such that its first derivative is continuous also, continuous, right. First derivative is continuous because it is flat. f3 dash x is also 0 throughout. So here f3 is such that differentiable and its first derivative is also continuous. First derivative is not continuous will not be the correct match for it. The first derivative is continuous, the correct match for it. For f4 I would say f4 was sine x squared sine 1 by x not equal to 0, 0 when x equal to 0. So x squared sine 1 by x. For f4, how it is very common example, we will see f4x is x squared sine 1 by x, x not equal to 0, 0 when x equal to 0, right. And we have to check it sine 1 by x now. At x equal to 0 we have to check it. See if you find limit of f4x, x tending to 0, so it is limit x square sine 1 by x. Sine 1 by x however oscillates between minus 1 and 1 when x is near to 0. When x tends to 0, x is very very close to 0, becomes close to 0, comes close to 0, sine 1 by x will fluctuate very rapidly between minus 1 and 1, but it is finite, it is something which is bounded, and here in front of it x square is there, x tends to 0, so x square tends to 0, so it is something 0 into something between minus 1 and 1, so 0 into bounded, I would say finite bounded thing, so it should be 0. And f0 is also, f40 is also 0, so function f4x is obviously continuous function. If you go for differentiability, f4 dash 0 at 0, so you'll see yeah, I will write from the first principle f4x minus f40, that is 0, upon x minus 0. So if I find this simple limit, again I'll get this, and using the same logic I can say 0 into something bounded minus 1 to 1, 0 into something minus 1 to 1 is 0. So function is definitely f4x is differentiable, f4x is differentiable at x equal to 0, differentiable at x equal to 0. But if you check the derivative, whether derivative is continuous or not, f4 dash x is what? You'll have to differentiate it. F4 dash x I can write because it is defined at 0, 0. It is 2x sine 1 by x. If you differentiate it using product rule, x square into sine 1 by x now. So x square as it is now, and what is derivative of sine 1 by x? Is cos 1 by x into minus 1 by x square. So you get finally minus of cos 1 by x, x not equal to 0, and at 0 as f4 0, f4 dash is 0, f4 dash 0 is 0, so it is defined at x equal to 0, and the value of f4 dash at x equal to 0 is 0. We have already checked it. But if you check the limit of f4 dash at x equal to 0, you will see limit x tending to 0, 2x sine 1 by x minus cos 1 by x, 2x sine 1 by x. The first part is 0 into something between minus 1 and 1, 0 into bounded is 0. But the second part, minus cos 1 by x, this fluctuates very rapidly between minus 1 and 1. It is not having a unique tendency. It will not go to a unique number. It is not going to a unique number. It is fluctuating very rapidly between minus 1 and 1 near 0. So it does not have unique tendency. So this limit will not exist. Limit does not exist here. So we can say that this function f4 dash function is not continuous at x equal to 0. Means f4 x function is such that its derivative is not continuous. Its derivative is defined at x equal to 0. Some function can be defined at some point, may not be continuous. The same thing is happening with the function f4 dash. f4 dash is defined but not continuous at x equal to 0. So function f4 x is differentiable at x equal to 0, but its first derivative is not continuous. Coming to the option, f4 goes with 3, differentiable at x equal to 0, but its derivative is not continuous at x equal to 0, as its limit is not existing here. So finally R was going with 4 and S is going with 3. So correctly option obviously option D is correct. All the 4 matching are correct. R4 S3, P2 Q1 R4 S3, P2 Q1 R4 S3. Right? Alright students. So I hope you understood it. All the 4 functions explained in detail. Yeah. Right. So option D is correct, as you can see. Thank you. Stay tuned.